Hi everyone, I'm Ridley Jones, a PhD student at the University of Washington. With my colleagues Michael Beach, Melinda Haughey, Will Sutherland, and Charlotte Lee, I'd like to talk to you about our paper, Construction of Shared Situational Awareness in Traffic Management. In our cities and beyond, the multimodal transportation network helps our shared life keep moving. Serious traffic incidents and congestion can interrupt that movement at a moment's notice. Behind the scenes, a cadre of people, software systems, sensors, algorithms, camera feeds, and vehicles from different agencies and organizations work to maintain a continually updated awareness of both normal traffic flow and major incidents and congestion. Understanding how these varied operational stakeholders develop their situational awareness and act on it is key for designing and improving supports to critical infrastructure. Before we talk about our own experience observing one specific setting, let's take a quick look at some of the key theories of situational awareness, especially work CSCW scholars might be less familiar with. Situational awareness, or SA, is a term that came to prominence during World War II, when the tactical advantages of matching pilot mental state to military objectives became clearer to the new field of human factors research. In the 1980s, Ensley's simple three-stage model of perception, comprehension, and projection of a specific situation became and remains the most prominent. Yet SA has proven difficult to study in some ways because it's often conceived as an internal mental state, but because it's also task-related, it should be connected to some kind of improved outcome. But Flock notes that it's hard to conclusively prove that good situational awareness leads to good operational outcomes. More recently, work such as distributed cognition, which examines how human technology systems share cognitive labor, has helped us go beyond what has been called a mentalist slant in Ensley's model. We hope to add to this work on distributed, system, and team situational awareness with our particular setting and its unique characteristics. Here we consider the research question, how do operators at the TMC construct and maintain a shared situational awareness for traffic management? Let's go over the setting where we observed situational awareness in action. Our work concerned people whose effective situational awareness has a pretty significant impact on our daily lives. We spent about 100 hours observing the daily work of operators at a City Department of Transportation's Transportation Management Center, or TMC for short. We then held semi-structured interviews with 11 participants, 7 of whom were operators, and 4 of whom intersected heavily with the operators. Usually, there were 2 or 3 operators at a time, monitoring hundreds of traffic cameras on both a large wall of camera feeds and their own desktops. We got to see the skillful and complex linkages between the individual operators and the wide variety of systems they use to make sense of the regional transportation network and figure out how to intervene to improve conditions as efficiently as possible. The actions they might take vary, but include tweeting incident screenshots, updating highway signs, contacting other agencies, or requesting resources to be sent to the scene, from either other divisions of the Department of Transportation or even other agencies such as the Fire Department. Here's a simplified diagram of the workspace. It's a very information-dense environment, and the operators have to juggle many different inputs when trying to develop and maintain their situational awareness. The cameras in particular are interesting because even though altogether they offer a close to comprehensive view of traffic conditions in the city, and are by far the most important SA tool in the TMC, even if all operators were maxing out their individual visual attention, they would not be able to collectively watch all of the cameras. And here's a quick look at our table of interviewees. So, what did we learn from observing operators develop their SA? One concept from Ensley's three-stage model is that SA is only one aspect of decision-making, and the gradual process of learning to use tools and systems, even though specific to supporting situational awareness, is a different kind of phenomenon. However, our specific observations of people using tools revealed a tighter coupling between tool and system use and SA, at least in the particular context of this sort of traffic management work. Operators collaboratively constructed an understanding of what their sensing tools did and didn't offer and how that changed over time. For example, more experienced operators imparted some of their mental map of the various traffic cameras to less experienced operators, giving advice as to which camera they should select to view certain locations. The best camera to use was not always the closest for various reasons. This is what we call the tool schema. It's the collection of contextual information about the various capabilities and gaps of tools used to obtain situational awareness and make appropriate decisions. Rather than being a background or prior task, it is actively negotiated and materially a part of what's possible to be aware of. After all, there's no pure awareness of a traffic incident for the people who manage it. Its actionable nature is always shaped by the tools that allow operators and others to perceive and qualify it. Also important, and usually not studied as explicitly, is how the operator's own actions and responsibilities intersect with those of other parties. For example, downtown streets are primarily the city's jurisdiction, while freeways are primarily the state's jurisdiction. This means that there are different procedures and information pathways for handling different locations, and different strategies for requesting and providing assistance between agencies. Because of the inherently interorganizational nature of this work, the jurisdictional schema is an active, material input into the contours of a situation. Additionally, some information can only be shared by certain parties. The fire department is allowed to tweet more detailed injury information than other agencies, for example. And this brings us to our next point, which asks us to take shared situational awareness even more broadly. This diagram shows part of the journey towards shared situational awareness. There's a physical reality we could call a situation, but it doesn't become something to maintain situational awareness about without active structuring by these tool and jurisdictional schemas, and probably others. Furthermore, operators in their particular role sit in the middle of an informational pipeline. Their SA has to be packaged and transmitted to their operational partners, as well as the traveling public. Largely via Twitter posts and dynamic message signs above the roads, travelers gain their own understanding of the situation and alter their behavior accordingly. This in turn dynamically changes the incident's physical reality. If the messaging works, travelers divert from the scene, reducing congestion and the likelihood of secondary incidents. So contributing to the situational awareness of others feeds back into the operator's own SA. So where do we go from here? First, we think the idea of a jurisdictional schema merits design exploration. This schema can be complex and tenuous, and tools that help operators in interagency response make better, faster, clearer sense of it have the potential to tangibly improve a wide variety of settings, such as environmental crises or supply chain models. While existing structures for responsibility sharing, such as the U.S. government's incident command structure, are highly valuable, they don't richly and responsively model the multi-layered, pre-existing jurisdictional landscape and what impacts that landscape can have on decision-making. The tool schema can augment existing HCI and CSCW work that models human-machine work systems, and may even offer the opportunity for building theory in these areas. The tool schema does not only take into account stated functionality for systems, but how operators blend overlapping, imperfect functionality to develop a contingent, nuanced understanding of an evolving situation. Finally, we recommend further ethnographic investigation in situational awareness-related settings. Most of the time our participants spent working was fairly low-key. High-intensity incident management happened only occasionally, and there was a more ambiguous transition between normal operations and active situation management. This helped to reveal finer gradations and qualities of attention management, such as superstition and storytelling, that ultimately helped participants be prepared for the unexpected. Controlled studies are clearly critical, but with a more contextual ethnographic lens, we can help with some of the quandaries of SA being locked up in the head. And with that, I'll wrap up and thank you for your attention. A big thanks to our wonderful participants and to the Federal Highways Administration for supporting this work. Feel free to get in touch with any comments or questions.